Okay, so today we're going to do more hypothesis testing, and instead of doing a z-test, we're going to actually do a t-test today. We're going to figure out, the main things that we want to figure out is when do we perform a t-test, and then how do we perform a t-test. So the first question is when we perform a t-test, we do a t when the data is not normal. And we can tell that this data is not going to be normal when we read through because our sample size is 18. And so if our sample size is less than 30, which 18 is less than 30, this is now going to be a t-test. So we now know it's going to be a t-test, and now we're going to kind of decide all this information based on it. So it says a fitness magazine advertised that the mean monthly cost of joining is $25. And then you work in an advocacy group to test the claim, and you find that your monthly cost is $26.25 with a standard deviation of 323. So you want to know, is their claim correct? So their claim is that their null hypothesis, their mean is 25. And your claim, or your alternative claim, is that they're wrong, so that it's not 25. So then we're going to run that in our calculator and find our p-value. So let's run that in our calculator. So I'm going to go up here and I'm going to hit stat. I'm going to do t-test today instead of z-test. And then their claim was that it was 25. Ours is 26.25 with a standard deviation of 3.23. And we have 18 trials. And we're going to say that's not equal. And we're going to hit calculate. And when I hit calculate, I can see that the p-value is about 12%. So my p-value is about 12%. And so do we have enough evidence to reject the claim? Well, they said only reject it if it's under 10%, so we cannot reject it, so we fail to reject their claim. So we don't know if their claim is right per se, but we know it's definitely not wrong right now. So their claim could be right, it could not be right. We might need to take more data to know for sure, but as of right now, we can't reject their claim. Let's try another one. Okay, so we're going to take this one. And again, I know this is a t-distribution. Whoops. I know this is a t-distribution because of the fact that it's 28 households, and 28 is less than 30. So we're going to run a t-test again. And then we're going to read through our information. They said the mean amount is this. And the consumer report wants to test the claim that the mean is now this, and we have a standard deviation of this. And we want to know, do we have enough evidence to reject our claim? So it looks like when you read through, we always have to make sure if it's equal to or not. It looks like we're going to test our mean to see if it's equal to. So our H null is it equal to this amount? Whoops. And our alternative hypothesis would be that the mean is not equal to that amount. And so then we would just test it. So let's bring out our calculator. I go stats, I go to t-test. I plug in all my information. I hit calculate, and it looks like we're not going to reject because that's close to 30%. I'm just going to double check all my info one more time. Yep. So that's about 28%. So we're not going to reject because our rejection point is 5%. So fail to reject. Let's do another one. Maybe one of these will reject. Okay, so again with this one, It's a t-test because it's 24. And we're going to look at our null hypothesis and our alternative hypothesis. Now this says, you want to be careful when you read this to see what they're trying to do. So it says a travel association claims that their mean daily lodging for the cost of 2 adults is at least $240. So we ran this test, and so their claim, or the original claim, is that the mean would have to be greater than 240. And our claim would be, well, we're not sure if that's true. I wonder if it's less than 240. And so then we can put all our data in again. And when we put all our data in, we're going to do 240 and then 233 because that was our sample mean. Our standard deviation was 1250 and we had 24 samples. And now we want the mean. So I always look to make sure my symbols match up, and it does. And then I always make sure my alternative hypothesis match up, which it does. And then we would find that this p-value is less than 1%. Like the p-value is crazy small. It's not even 1%. It rounds up to 1%, but it's still crazy small, which is definitely less than 10%. So we reject the idea that the housing would be over $24. It's just not going to be. We don't know where it's going to be, but it's not going to be over $24. Let's do one last one. Okay, so now we have a list of data. I'm going to show you how to do this one. So a brochure basically says the mean class size is fewer than 32 students. So we've been told that our hypothesis, our original hypothesis, is our mean is less than 32. So our alternative hypothesis is that the mean is greater than 32. And then we're going to go to our calculator. And since they gave us data, we're going to go to our list. And we want to type in all of these data points, if I can type correctly. And I used to be a lot quicker at this, but we'll see if I can get it all in. And after I type in all my data, we're going to hit, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, and I have 18 data points, so we are good. We're going to go to stat. We're going to go to t-test. You see this thing that says data instead of stats? You won't use this very often, but if you do get a data list, and we put ours in list 1, and they said 32 students was our original mean, and it will now calculate everything. But we need to make sure it matches up. So we want our symbol facing away from our mu, which is true. And then I run calculate, and our alternative hypothesis 32. So it looks like their data set is really, really close. Which I'm just curious. That makes sense. Why it would be so crazy close. Because our means are very, very, very close. So, what we can see with this is that when we run this t-test, I'm going to make sure my symbols are right. So we wanted to see their original assumption was there was fewer than 32 students. We want to test the alternative, which, what's the odds that it's more than 32 students? It's really close, but that's because we have a very high mean, or a very close mean to 32 with a standard deviation of 4. So it's all very, very close in there. So there's a high probability that that is true. So we would fail to reject the null hypothesis. Try the different things today. If you get stuck, just let me know.